USS Preble DDG-88 launches its HELIOS laser weapon. Date and time, February 4, 2025, 11:51 a.m. Event Overview. On February 4, 2025, the USS Preble DDG-88, an Arleigh Burke-class destroyer, marked a significant advancement in naval warfare technology by successfully testing its high-energy laser with integrated optical Dazzler and surveillance HELIOS system. During the test, the HELIOS system effectively shot down a drone showcasing its operational capabilities in a real-world maritime environment. Background on HELIOS. Developed by Lockheed Martin, the HELIOS system represents a major leap forward in the U.S. Navy's efforts to integrate high-energy laser weapons into its naval fleet. The system is designed to counter a variety of aerial threats, including drones and potentially missiles. Delivering over 60 kilowatts of directed energy with an operational range of up to 5 miles 8 kilometers. This dual capability allows the HELIOS system to perform both hard kill operations, destroying targets, and soft kill operations, disrupting electronic systems of hostile threats. The HELIOS laser weapon is part of a broader initiative by the Navy to modernize its defense capabilities amid the increasing threat from unmanned aerial vehicles, UAVs, and anti-ship missiles, particularly in strategic regions such as the Red Sea and Gulf of Aden. Details of the test. According to a report by the Pentagon's Director Operational Test and Evaluation (DOTNE), the test was conducted during fiscal year 2024. While specific details regarding the location and exact timing of the test remain classified, it was confirmed that the USS Preble successfully validated the performance and functionality of the HELIOS system against a target drone. The demonstration was described as pivotal in advancing the Navy's shipboard laser capabilities, which have faced delays and challenges in previous years. Vice Admiral Brendan McLean, the Naval Surface Forces commander, emphasized the urgency for operational laser systems, highlighting the ongoing threats posed by drone warfare. The successful test of HELIOS on USS Preble is seen as a critical step toward making laser weapon systems a staple in naval engagements. Strategic importance. The integration of the HELIOS system is crucial as the Navy faces a barrage of drone threats, especially from Iran-backed Houthi rebels in the Middle East. The Navy has been actively engaged in counter-drone operations, and traditional missile inventories are often strained due to their finite nature and high costs. The HELIOS laser weapon offers a cost-effective solution with its low operational cost per kill and the ability to engage multiple targets without the physical limitations of conventional ammunition. The Navy's strategy includes not only deploying HELIOS but also enhancing its integration with existing systems such as the Aegis Combat System. This integration allows for improved target detection and response capabilities, thereby increasing the overall effectiveness of naval operations. Development challenges and future prospects. Despite the advancements with HELIOS, the U.S. military has encountered several challenges in the effective deployment of laser technology. Reports indicate that while considerable funding, approximately $1 billion annually, has been allocated for the development of directed energy systems, practical deployment has often lagged. Challenges include aligning the technology with operational needs and transitioning these systems from the lab to the field. Looking forward, the Navy envisions a future where the HELIOS system's power output can be increased to 150 kilowatts, which would further enhance its effectiveness against more complex threats, including larger drones and subsonic cruise missiles. Conclusion. The successful test of the HELIOS laser weapon aboard the USS Preble represents a significant milestone in the U.S. Navy's integration of advanced laser technology into its maritime operations. As modern threats continue to evolve, the HELIOS system is positioned to play a pivotal role in the Navy's defense strategy, addressing the challenges posed by drones and missiles in a cost-effective and efficient manner. The journey toward operationalizing shipboard laser weapon systems, however, remains fraught with technical and strategic hurdles that the Navy must continue to navigate in the coming years. For further updates and detailed reports on naval advancements, please refer to the Pentagon's official communications and defense industry publications. The recent successful test of the HELIOS laser weapon system aboard the USS Preble DDG-88 brings several counterintuitive points to light regarding the nature and development of modern military technology, particularly laser systems. 1. Power supply misconception. One of the most striking features touted about HELIOS is its unlimited supply of power. This statement could lead to the misconception that the laser weapon is entirely self-sufficient and can operate indefinitely without constraints. However, the reality is that while the system is powered by the ship's electrical system, the actual operational duration of the laser is still limited by the ship's power management capabilities and the thermal limits of the laser components. The idea that a laser weapon can simply fire forever is misleading. It must manage energy efficiently and cool down after prolonged use, which contrasts with traditional munitions that can be fired in quick succession until depleted. 2. Cost-effectiveness versus practical deployment. The HELIOS system is presented as a cost-effective solution with a low cost per kill compared to traditional missile systems. However, the effective deployment of such technologies is hampered by operational challenges and the perceived need for extensive training and integration into existing naval frameworks. This creates a paradox where, despite the potential for lower operational costs, the upfront investment in technology development and integration combined with the slow pace of deployment can result in higher overall costs. 3. Operational limitations. There is a perception that laser weapons can easily replace traditional kinetic munitions. However, the current state of laser technology, including HELIOS, limits it to specific scenarios such as point defense against small, slow-moving aerial threats like drones. In contrast, traditional weapon systems can engage multiple targets over long distances and in varied environmental conditions. This selective capability means that while lasers can augment naval defenses, they cannot fully replace conventional weapon systems, which could lead to over-reliance on a technology that still has significant operational constraints. For long development timeline, the frustrations expressed by Navy officials regarding the slow pace of laser development highlight a counterintuitive truth. Despite significant funding and technological advancements, the transition from conceptualization to operational deployment can take years if not decades. The HELIOS system's development timeline from initial contracts to recent testing exemplifies this reality. This lag is not solely due to technological challenges but also involves bureaucratic and strategic hurdles that can stifle innovation and implementation. 5. Public perception versus reality of laser weapons. The media often portrays laser weapons as futuristic and almost magical solutions to modern warfare, capable of engaging targets with pinpoint accuracy at the speed of light. This perception can overshadow the gritty realities of laser systems, such as their susceptibility to atmospheric conditions, limited engagement range against certain threats, and the need for continuous aim and energy application to effectively neutralize targets. Thus, while the HELIOS system represents a significant step forward, it is not a panacea for all naval warfare challenges. 6. Integration challenges. The HELIOS system's integration with existing naval combat systems such as Aegis underscores a broader issue of interoperability in military systems. The expectation that new technologies can seamlessly integrate into existing frameworks often proves overly optimistic. The complexities of coordinating a new weapon with established systems can create friction that hinders effectiveness in combat situations, challenging the assumption that advanced technologies will automatically enhance operational capability. In conclusion, while the USS Preble's successful test of the HELIOS laser weapon system marks a significant advancement for the U.S. Navy, it also illustrates several counterintuitive aspects of military technology development and deployment. The realities of power supply limitations, operational constraints, integration challenges, and the misalignment between public perception and technical capabilities all serve to remind us that advancements in military technology are often accompanied by a host of complexities and challenges that must be navigated carefully. The successful testing of the high-energy laser with integrated optical Dazzler and surveillance HELIOS system aboard the USS Preble DDG-88 marks a pivotal moment in naval warfare technology and strategic defense capabilities. While many key points of this report have been highlighted, several critical aspects may be overlooked by the general public, yet they hold significant implications for military operations and the future of naval engagement. 1. Dual functionality of HELIOS, hard kill and soft kill. One of the most crucial yet often overlooked features of HELIOS is its dual capability for both hard and soft kills. This means that the system can not only destroy aerial threats like drones but also disrupt their electronics, rendering them ineffective without physical destruction. The ability to blind or confuse enemy sensors through its optical Dazzler feature can significantly enhance the survivability of naval vessels in contested environments. This capability is particularly relevant as adversaries increasingly employ advanced drones and electronic warfare tactics. Significance: the implications of this dual functionality extend beyond immediate combat scenarios. It reflects a shift towards more nuanced engagement strategies where the goal is not just to destroy but to neutralize threats while maintaining operational integrity. As warfare becomes more complex, the need for systems that can adapt to multiple types of threats is crucial. 2. Integration with Aegis Combat System. The HELIOS system's ability to integrate with the Aegis Combat System is another critical point that can be easily overlooked. The Aegis system is renowned for its advanced radar and missile defense capabilities, and the addition of HELIOS means a transformative enhancement in targeting capabilities. This integration allows for coordinated responses to threats, combining traditional kinetic weapons with directed energy capabilities. Significance: the synergy between HELIOS and Aegis not only improves the effectiveness of naval defense but also represents a significant evolution in how naval forces can respond to diverse threats simultaneously. This integrated approach could set a new standard for future naval engagements where rapid adaptability and multi-layered defense are paramount. 3. Cost-effectiveness and sustainability. HELIOS promises a low cost per kill compared to traditional munitions, which can be significantly expensive and logistically challenging. The capability to engage threats at the speed of light means that HELIOS can potentially engage multiple targets in quick succession without the same logistical burdens associated with reloading missiles. Significance: in an era where defense budgets are often constrained and the cost of warfare continues to rise, the economic benefits of laser systems like HELIOS cannot be understated. This cost-effectiveness may allow for a more sustainable approach to defense, enabling longer operational timelines without depleting missile inventories. Moreover, the reliance on a ship's power supply for the laser means that naval vessels can maintain a continuous defensive posture without the need for resupply. 4. Challenges in deployment and transition. Despite the promising capabilities of HELIOS, the report highlights significant challenges related to the deployment and transition of laser technology from the lab to operational use. The Pentagon's annual Director Operational Test and Evaluation (DOTNE) report points out that while substantial funding is allocated for these technologies, actual deployment has often lagged due to operational alignment issues and the complexities of integrating new systems into existing naval frameworks. Significance: these challenges underscore the military's struggle to keep pace with rapidly evolving threats, particularly from adversaries that are increasingly proficient in drone warfare and anti-ship missile technology. The slow transition from testing to operational deployment can leave naval forces vulnerable at critical moments. Addressing these hurdles is essential to ensure that advancements like HELIOS can be effectively utilized in real-world scenarios where timing and preparedness can mean the difference between success and failure. 5. Long-term vision for directed energy weapons. The Navy's long-term vision includes scaling HELIOS to deliver even more power, with aspirations of reaching up to 150 kilowatts. This ambition signals not just an incremental improvement but a potential paradigm shift in naval defense capabilities that could redefine engagement rules in future conflicts. Significance: the prospect of higher power outputs opens the door to countering more complex threats such as swarming drone attacks or sophisticated anti-ship missiles. As adversaries continue to enhance their arsenals, the Navy's ability to innovate and expand its directed energy capabilities will be vital for maintaining maritime dominance. This long-term vision also reflects a broader trend within military strategy that prioritizes technological advancement as a means of deterrence and defense. 6. Operational context and real-world relevance. The operational context of the HELIOS testing, specifically in regions like the Red Sea and Gulf of Aden, where U.S. naval forces regularly encounter hostile drone threats, should not be overlooked. The Navy's recent operational engagements against Houthi rebels exemplify the pressing need for effective counter-drone capabilities. Significance: understanding the real-world relevance of HELIOS testing emphasizes the urgency of advancing naval technologies in response to immediate threats. The testing results are not merely technological milestones, they also represent a proactive approach to evolving combat scenarios where traditional methods may fall short. The ongoing conflict dynamics in these regions highlight the critical role that advanced technologies will play in ensuring the safety and efficacy of naval operations. Conclusion. In summary, the successful testing of the HELIOS system aboard the USS Preble signifies more than just a technological achievement, it embodies a strategic evolution in naval warfare. The dual functionality, cost-effectiveness, integration with existing systems, and long-term vision for directed energy weapons present a comprehensive narrative that underscores the importance of adapting to modern threats. Addressing the challenges of deployment and operational integration will be crucial in leveraging these advancements effectively. As global threats continue to evolve, the Navy's commitment to innovation through systems like HELIOS will be pivotal in maintaining maritime security and strategic advantage. 1. Operational capability and dual functionality of HELIOS. The HELIOS high-energy laser with integrated optical Dazzler and surveillance system represents a significant advancement in naval weaponry, capable of both hard kills, physically destroying targets, and soft kills, disrupting electronic systems of threats. With its operational range of up to 5 miles and the ability to deliver over 60 kilowatts of directed energy, HELIOS addresses modern threats such as drones and missiles effectively. This dual functionality enhances the U.S. Navy's ability to defend against a variety of aerial threats, particularly in high-tension regions. 2. Strategic importance and cost-effectiveness. The integration of HELIOS into naval operations is driven by the pressing need to counter escalating threats from UAVs and anti-ship missiles, especially in areas like the Red Sea and Gulf of Aden. Navy officials emphasize that shipboard lasers like HELIOS can alleviate the logistical and financial burdens associated with traditional missile inventories, which are limited and costly. By providing a renewable energy source for defense, HELIOS allows for sustained engagement without the same concerns over ammunition depletion faced with conventional weapons. 3. Development challenges and future prospects. Despite the advancements represented by HELIOS, the U.S. military has encountered significant challenges in the development and deployment of laser weapon systems. With approximately $1 billion allocated annually for directed energy systems, the Pentagon has struggled to transition these technologies from the lab to operational use. This includes aligning operational needs with the capabilities of new systems, as highlighted by a 2023 Government Accountability Office report. The future of HELIOS may involve increasing its power output to 150 kilowatts, allowing for even greater effectiveness against more complex threats. 4. Integration with existing naval systems. HELIOS is designed to complement the Aegis Combat System, enhancing its targeting capabilities and allowing for coordinated defense operations. The integration of HELIOS with existing naval technologies signifies a strategic move towards modernizing the Navy's maritime defense approach. This collaboration is essential for ensuring that new advancements in laser technology can be effectively utilized in conjunction with traditional systems, ultimately improving the Navy's overall operational readiness and adaptability in the face of evolving threats. 1. The USS Ponce AFSBI-15 and its laser weapon system. The USS Ponce was an amphibious warfare ship that notably tested the laser weapon system laws in 2014. It became the first Navy ship to deploy a laser weapon system, successfully shooting down drones and demonstrating the potential of directed energy weapons. The laws operated at a lower power level compared to HELIOS but was significant in validating the concept of laser weapons in naval operations. 2. The Airborne Laser ABL. Developed by Boeing, the ABL was an experimental weapon system mounted on a modified Boeing 747-400F. Its purpose was to shoot down short to medium-range ballistic missiles during the boost phase of flight. The program began in the early 2000s and demonstrated laser technology's potential for missile defense. However, despite successful tests, the ABL program was ultimately cancelled in 2012 due to budget constraints and challenges related to operational deployment. 3. The Navy's laser weapon system laws aboard the USS Portland LPD-27. In 2021, the USS Portland successfully engaged and destroyed a drone using the Laser Weapon System Demonstrator LWSD. This marked a continuation of the U.S. Navy's efforts to develop laser weapon systems for modern naval warfare, showcasing the ability to counter aerial threats in a real-world scenario. The Portland's tests further validated the Navy's commitment to integrating advanced technologies like lasers into its fleet for enhanced defense capabilities. Future outlook, predictions for the USS Preble DDG-88 and HELIOS laser weapon system. The successful demonstration of the high-energy laser with integrated optical Dazzler and surveillance HELIOS aboard the USS Preble marks a pivotal moment in naval warfare technology. The integration of laser systems into military operations is anticipated to evolve significantly over the next decade, influenced by advancements in technology, changes in military strategy, and the dynamic nature of global threats. 1. Increased integration of directed energy weapons. As the U.S. Navy continues to refine the HELIOS system, we can expect an increased integration of directed energy weapons (DEWs) in naval fleets. The HELIOS system's dual capabilities, both hard kills and soft kills, will likely be enhanced with further technological advancements. Future iterations may feature higher power outputs, potentially exceeding 150 kilowatts, enabling the system to engage larger and more complex threats, including anti-ship missiles and swarms of drones. The U.S. Navy plans to leverage these capabilities to maintain maritime superiority, especially in contested regions. 2. Shift towards cost-effective defense solutions. The rising costs associated with traditional missile systems, coupled with finite inventories, will drive the Navy to adopt more cost-effective solutions like laser weapons. The HELIOS system's low cost per engagement and renewable energy nature will make it an attractive option for fleet commanders. The ability to engage multiple targets without the logistical burden of resupply will be a significant advantage in high-intensity conflict scenarios. This shift is likely to influence procurement strategies and budget allocations within the Department of Defense. 3. Enhanced multi-domain operations. The HELIOS system will likely play a crucial role in multi-domain operations where naval, aerial, and cyber capabilities must function in concert. Integration with existing systems like the Aegis Combat System will enhance situational awareness and targeting accuracy. Future upgrades may include artificial intelligence (AI) for improved threat assessment and engagement coordination, allowing for rapid responses to incoming threats. This evolution will be essential as adversaries increasingly employ sophisticated drone and missile technology. 4. Expansion of laser weapon systems across platforms. The success of HELIOS aboard the USS Preble may catalyze the deployment of laser weapon systems across various naval platforms, including aircraft carriers, amphibious assault ships, and smaller vessels. The versatility of DEWs will encourage the Navy to explore their use in diverse operational contexts, from fleet defense against aerial threats to patrol missions in contested waters. Additionally, this trend may extend to allied navies, fostering international collaboration on laser technology development and deployment. 5. Focus on countermeasures against emerging threats. As threats from drones and unmanned systems proliferate, the Navy's emphasis on laser systems will intensify. The HELIOS system is particularly suited to countering swarms of drones, a tactic that has gained prominence among adversaries. Future developments may include specialized laser variants tailored for specific threat profiles, such as high-power microwave systems designed to disable electronics in enemy drones or vessels. This focus on countermeasures will enhance the Navy's readiness to confront new warfare paradigms. 6. Challenges in operational deployment and sustainability. Despite the promise of laser technology, challenges remain regarding their operational deployment and sustainability. Issues such as thermal management, power supply limitations, and atmospheric effects on laser performance will require ongoing research and development. The Navy will need to address these technical hurdles to ensure that laser systems like HELIOS can perform reliably under combat conditions. Furthermore, training personnel to operate and maintain these complex systems will be essential for their successful integration into naval operations. 7. Evolving strategic doctrine and military engagement. The integration of HELIOS and similar systems will likely influence U.S. military strategy and engagement policies. As laser technology becomes more prevalent, the Navy may adopt new doctrines that emphasize the role of DEWs in deterrence and defense. This could involve reassessing engagement rules and operational protocols to maximize the capabilities of laser systems in various conflict scenarios. Additionally, the proliferation of laser technologies among adversaries may lead to an arms race in directed energy capabilities. 8. Collaboration with private sector and research institutions. The future development of laser weapon systems will benefit from collaboration with the private sector and research institutions. Partnerships with companies like Lockheed Martin will be crucial in driving innovation and overcoming technical challenges. The Navy may also engage in joint research initiatives with universities and think tanks to explore new applications and technologies that can enhance laser weapon effectiveness. Conclusion. The successful test of the HELIOS system aboard the USS Preble marks a significant step toward the operationalization of laser weaponry in naval warfare. Over the next decade, we can expect to see the U.S. Navy increasingly integrate DEWs into its strategy, focusing on cost-effective solutions to counter emerging threats. While challenges remain, the evolution of the HELIOS system and similar technologies will play a vital role in shaping the future of naval combat and defense strategies globally. As these advancements unfold, the Navy's ability to adapt and innovate will be critical in maintaining maritime superiority in an ever-changing security landscape.